He completed his PhD from MNIT Jaipur. In 2020, he was awarded from MHRD Fellowship during PhD research work 2016 to 2020. His research interest is in real-time design for biomedical application, AI in healthcare, analog circuit, digital VLSI design, and machine learning for computation. He published several research papers in peer-reviewed journal and conference. He is also reviewer of reputed journal and conference. He has a granted patent on wearable device for diabetes care. He has several published national and international patents. He got 3 research seed grant during his academic career at university level. He is a member of IEEE, IEI, IETE, OSA, ISTE, and SPIE. He served as session chair and TPC member in the various reputed international conference. He delivered session and hands-on in a various academic institute. He attended various FDP and STTP for acquiring recent trends. His teaching experience in the various subjects such as electromagnetic theory, hardware and software, real-time system design, embedded system design, advanced microcontroller and interfacing, instrumentation and measurement, analog and digital VLSI. So now it's over to you, Pratik.
Yeah, thank you, sir. Thank you for a short brief, and hope so. This session will be fruitful to the candidates. Those are looking interested and motivated for the learning the area which is related to the regression models, and the regression models are useful. These are the forecasting models and
Pratik,
predicting models.
share your full screen.
Okay, sir. I already shared full screen, sir.
No. It is not full
It is
screen.
not. It is not visible right now.
No, it is visible, not it is in a full screen.
Okay. Okay, I am just sharing again. Okay. Hope so. I think it is visible now.
Yes. Please go ahead.
Okay. So I hope this is visible full screen. So this is available in full screen also.
Yes.
Okay.
Now please go ahead.
Okay. So I'm just giving just brief introduction about the regression model. So this regression model is always useful for different uh, area, such as healthcare domain and agriculture domain. Suppose somebody is working in power optimization area. So wherever we are going through the forecasting and we are predicting something based upon some features and parameters, so the regression models are utilized, and definitely these utilized regression model could be implemented for the better performance and the precise prediction. So it is going to deliver the features and the different regression models using Python. So a lot of people are working on different frameworks. A lot of people are working using different softwares, and definitely the models could be framed or could be trained using different models based upon the different concept. And definitely a lot of algorithms are available. Those are definitely precise and optimized as per the data characteristics, or we can say the data behavior. So based upon this one, I'm just going to overview about this Python. Python is easily available everywhere, and anyone can utilize and anyone can implement different machine learning algorithms and predicting algorithms using Python, because the Python libraries are easily available. So just giving an overview, because everybody knows about the Python. So Python libraries for data science, definitely we are using NumPy, SciPy, Pandas, SCI, Kit-learn, and for the visualization point of view, Matplotlib and Seabons are available. So we're just talking about the NumPy. So NumPy definitely will be used for different kind of arrangements, like multi-dimensional arrays arrangements, matrices arrangements. And suppose if you are just going to align the arrays, matrix and data, and suppose you have the Excel sheet and you are going to attach the data into the form of the different of arrays, because right now if you're going to implement any algorithm for the prediction point of view or classification point of view, So these array formations are required as we are going to utilize number of rows and number of columns as an input and output variable. So once a while, if you will be having the arrays into the form of the inputs and outputs, then definitely we would be able to form the models, and the formed models definitely will be considered as a validation and trade testing purpose. So generally NumPy is used for multi-dimensional array and matrix alignments, and it actually provides the vectorizations for the mathematical different operations. So just talking about the SciPy is generally called for the correction of the algorithms for the different linear algebra. For if you're just going for different equations, different partial differential equations, we are going for the integration, differentiations, and different statistical parameters, then we use SciPy. So why we are calling the libraries, as whenever we are calling the libraries using the Python framework, so by calling the libraries, the data could be aligned, and the aligned data would be used for the training purpose and validation purpose. So these inbuilt libraries can be directly used, and this is an advantage of the Python framework whenever we are using the data science kind of the activity, or we can say that we are going through the data processing. So we have to use these library directly first of all. So this is the part of the algorithm initializations and preparation of the data. So just like this pandas, so pandas is generally used to prepare for the data structure. We have to arrange as a table like for data, and definitely we need to arrange it series and parallel mode. If we are going to manipulate the data by using the reshaping, if we have to merge the data, we have to sort the data, we have to slice, and we have to aggregate the values for the formation of the different input values, then we have to use the pandas. So whenever we are calling the pandas, then we have to understand that we have to use the framing, we have to use the slicing, we have to use the sorting. So anyhow we can say the reshaping and merging kind of preparation will be used for the pre-processing of the data. So whenever we are going through the pre-processing of the data, so we have to arrange the data into the form of the inputs or the outputs, because the time we are only arranging the data into the terms of the inputs and outputs. Inputs or outputs would be considered into the form of the columns, where we have the data into the different iterations, multiple iterations. So if I am just going through the collector data by different number of patients and objects, definitely one line will be representing the inputs and corresponding outputs, and the multiple lines will be representing the patient data, and there these all kind of the lines into the form of the rows would be considered for the formation of the learning model, that can be the regression model or the classification models. So just coming to the point again, so pandas definitely will be used for the data manipulations, and in the data manipulations, the reshaping, merging, sorting, slicing, aggregations, framing, so all these things are being considered. So the pandas libraries, so we can say the NumPy, SciPy, Panda libraries, which are easily used and usually used as a pre-formation of the data. Okay, and the next, which is scikit-learn. So this actually important library provides the machine learning algorithm interactions, in which where we can perform the classifications, where we can perform the regressions, clustering, model validation, training, lot of machine learning related or data analysis related algorithms can be performed by you calling this SKS scikit-learn library over here. So first of all, by using all this one, we have to build on NumPy, we have to build SciPy, and we have to build on Matplotlib. So if we are just going for the visualization of the learning models, we are going to visualize the data after predictions. We are going to visualize the data after the classifications. Then Matplotlib is required. Matplotlib is required for the analysis point of view. It's a visualization point of view. So for the visualization point of view, there may be a lot of things. So where we are just going through the Matplotlib, so definitely it is 2D plotting libraries, and definitely it is required for the publications quality figures. Suppose you are going to observe the data, and you are required to represent the data into the form of the different analysis, like a scattered plot and a correlation plot. Suppose if it is required for representation of bar chart and histograms and pie chart. So a lot of statistical plots are required, so we have to call for this matplotlib. And if you are using the matplotlib library, so definitely this library will be helping to provide the plotting of 2D figure, and these kind of the figures are definitely important for the publication point of view, as the Python generated plots are very uh, of very fine qualities, and definitely helping to us if it is providing sufficient data for the plotting over here. So similarly, C1 is also similar to the matplotlib, except this C1 is required to represent for the 3D view over here. And definitely it can be used for the representation of the classification model. Then we are going to represent the output from multi-dimensional path. So for the multi-dimensional data, we used to connect with the C1 also. So we start with the Jupyter. A lot of frameworks are there. Means many of the people are using the Python. That is the online Python. So we can use the Google Colabs, and a lot of people are using Spider, Jupyter. Lot of frameworks are available there for. But what I'm thinking, just Jupyter is used very frequently, very usually people are using over here. So just take an example, just short example, gradient of the instructions which are used to load the libraries. So I'm just going to represent only the Python libraries which are used to import. So import numpy. So this is proper way to represent, and it is proper way to call the libraries which are import numpy. So definitely numpy will be used to call the data, to arrange the data into the form of table, and that will be called as np, import numpy as np. And again it is scipy as a sp. And when we are going to align, after this calling of the data, it is required to arrange, or it is required to frame the data into the form of the inputs and the expected output and corresponding output. So we have to import again the next library, which is pandas as pd. So whenever we are going through the visualization of the data after the algorithm implementations, or the computation model implementation, though, so matplotlib is required to provide the visualization of the data. So this matplotlib is being imported by the import matplotlib as mpl. And same as if we have to import the data for the visualization into the form of the 3D representation, so we have to use the cborn as sns. Okay, so just taking very small examples, it is not related to any kind of the data, and it is not related to any kind of the attachment of the file. Here there may be a lot of possibilities to attach the data file, that maybe the call for the data from the csv file. So if suppose the file is available at the url, definitely it is available online, so we can use directly df is equals to pd dot read underscore sb. So df is being represented for the framing of the data. It is data framing. So when we are calling the data, it is pd dot read. So pd dot read provides a recommendation for data is being read by the particular site. So site is given over here. So if suppose we are going to represent the data, so it could be directly called from the online site, and there are so many possibilities to call the data also from the excel file, from the sas file, from the sdf file, from statistic files where we have the data file also. So a lot of things, a lot of possibilities are there to avail for file attachment to call the data. So a lot of things are there. So where we have the different things to call the libraries, and after that we have to call for the data, and it is required to attach with the library. So if we are going to reform, or we are going to frame the data, so it is required to have for input and output segregations. So for the example, I have represented the first 5 records where it is representing for dhead. So here this is the head representation files where we are going to represent the rank, discipline, phd, service sec. Because I have taken this is only for the examples, and examples is going to represent it for the data framing over here. So if I am going to represent the 5 records, so I will have the 5 records data for the visualizations after calling for the data slicing or the framing over here. So likewise we can take the data from first 10 to 20 and then 50 records, and we can guess to view the last few records also. We can go through various the data representations that can be highlighted, that can be focused, that can be used for the implementation, that can be used for the calibrations. And definitely, if we are going to test the system, we're going to test the algorithm, then we can use a particular line as an input for recall, and the algorithm or the model could be easily adjusted and confirmed that it is properly precise or not. So likewise, we have different data types for the data framing, and these are definitely helping to us. So just going to reframe the data again by using the data types. So by using data types, we can have the representations, like suppose if it is going to represent by column type, so we can directly write down df, because there are so many possibilities to call the data after the framing or before the framing. Suppose you're going to frame the data by using their own heads, then we can have the data representation by the 5 records and 10 records and 20 records. But suppose if you're just going to call the single data as an input or as an output, so we can have representation as their own individual column that may be useful for us. Suppose we are going to analyze a single feature to represent any kind of the algorithms, and we can call the single algorithm by using this particular syntax. This is df, and that is the data type, so it is d type. And we are having a lot of representations that can be represented. As we know, the ranks, for the example, the rank is given for the unsupervised case, so it is an object. Discipline also is object. So if suppose something is available into the form of the values digits, so it can be represented by integer 64. Otherwise, it will be an object. So we can call for the data framing by using the data types. So likewise, we can use by attributes, we can use by methods. Different methods are there, like suppose we are going to describe, we are calling for the maximum value, we are calling for the minimum value, we are going to call for the mean, medium, standard, and samples. So these are the possibilities where we can call the instructions, and by calling the instructions, we are available to frame the data as usually. Okay, so a lot of things are there. So suppose if you are going to frame the data by group also, so by group you can deploy the data, and you can call for the data for the different level of inputs. Suppose we are going to call the inputs, number of inputs from the different channels, so we can call by group only. So by the group only we can call for by the rank, by their name, so it is being mentioned over here. So this is also another method to call the data and to frame the data by this group by method. So we can use directly, and we can use the filtering process also. Suppose we have number of data, number of inputs, we are going to minimize the inputs, so we can call for the filtering process, and we can directly use the different boolean operators for the getting subset of the data. So this is also one of the method for using the data frames. And the slicing also, that already been discussed. So just going to discuss about the data frames, it is for the location also. Suppose I am just going to represent the data, and I need to recall the data for the location. So this is also under the frame of the data. So we can use the df underscore sub dot loc. So where it is being represented that 10 to 20, the rows in between 20 to 20, I need to call these rows for the observations where I need to recall again for the input or output, the columns which are rank, sex, and salary. Suppose I'm just taking an example for the ranks. I need calling about the professors and their gender, and definitely their salaries also. So if I'm just calling for the data and just giving some specific locations in between 10 to 20 rows, we are just going to observe the data in between the rows from 10 to 20. So I need to observe how much kind of the available features there. So these features can be aware, and these features can be used by using the particular method, which is location, that is the loc. So if I'm just going to use another which is iloc, so this is the difference between iloc and loc. So the difference is that if we need to select the range of the rows with the label that can be used, that is the loc. But if suppose I am using the positions, If I am using the positions only, here in this situations I am using the object, here I am using the positions. The positions means the column position, the column position which is given over here, it is a position from 0 3 4 5. So column position for 0 3 4 5 that can be used, and the data can be taken from the row number 10 to 20. So the 10 to 20 data will be represented, and it is recalled or framed by ILOC instruction. So this is another method for the representation of data framing by ILOC. So just giving small brief representations for the different ILOC where we can represent. So this is df.ilOc. If just going to represent the first row, so it is ILOC 0. If you're going to represent I plus 1th row, then definitely it is ILOC I. And if it is represented by the last row, then it is -1. So these are very specific. We should not be confused into this matter where we have to use the first and last row. And if you're just using the first and last column, so it can be represented like this. The first column it is colon, there is a comma 0, and the last column it is colon then comma -1. So this is very common, and just going to skip this part as it is already discussed in very introductory part for the Python programming. So again, it is the new method for the data framing. It is sorting. If you just going to sort the data, it is required as per the data specifications. So we can perform the instructions by enhancing the instruction which is df underscore sorted, so that we can call the sorting of the data by services. So we can provide by service, and definitely the data will be sorted as easily as possible. So that is also the method for the data framing. That is so just coming to the main program, as it is required to understand means when we are going to predict the glucose values using the different regression models. So over here, so it is easy. I'm just going to implement as usually. So whenever we are just writing any Python program for implementing linear regressions or any kind of the regression model for any kind of the prediction. So for the example I have taken for the glucose prediction over here. So for the glucose prediction, I have taken the parameters. So we'll discuss later. First of all, it is required to call the libraries. So libraries are being called. So NumPy, Pandas, Matplotlib libraries, and Seaborn libraries, all these 4 libraries have been called. After that, I called the library which is linear regressions. And in this linear regression, we need to require to import it is R square score, mean square error, and it is so just took the data which is randomly selected from the number of patients which are 100. So number of selected data is being represented over here. You can see that is a part. So right now I'm just going to represent which is age is equals to np dot random dot randi integer. This is random integer value. So this syntax is represented and demonstrate actually the 20 is the initial value, that is minimum value where we are going to represent the age of the patient. It means we have taken the 100 number of patients, and this 100 number of patients, the minimum age of patient means the youngest person is of the 20 years old, and the oldest person is 70 years old. And here is n is representing by number of patients. So whenever we are calling for the instructions kind of np dot random integer value, so the first number will be representing the minimum value. It is the minimum value of the size. Second number is being represented by the maximum value, and the last value is representing the size of the data. And similarly, if I am just calling this random value representation with the normalizations, so over here the first value is representing by the data, it's a mean value actually. So 26 is, we can say it is a median value. The 5 is being represented, it is plus minus 5. It may be incremental 5 or maybe a decremental 5. So we can say this 5 is actually representing the windowing of this 26 number of value of 26. So suppose if I'm just going to consider the body mass index of the patient, which is being considered the median value of 26, and over here the 5 which could be considered as a maximum 31 BMI would be considered, and minimum to minimum it is 21 would be considered, and N is representing by number of patients. Similarly, BP can be considered as the blood pressure is being considered for the input, or we can say the attributes for the finding the glucose value. So here for this condition, we have taken the random values of the patients where we have the blood pressure value. This is systolic blood pressure value 120. So 120 is the median value of the systolic blood pressure, and plus minus 10 could be considered as a minimum and maximum range to find to findings for the findings. And definitely N is again I am going to represent the size of the data. And again for the insulin representation, insulin value could be provided by the medium value. It is 80 micro liter per samples. We can consider as a representation of the insulin secreted, insulin provided to the patients, and plus minus 20 could be considered as a minimum and maximum value accordingly. And N is again representing by the size of the data. Okay, so here these four attributes we have considered for the finding of the glucose value of the patients. So initially it is required to calibrate the data by analyzing the age of the patients, the body mass index, and the blood pressure and insulin level representations. So glucose values definitely will be depending upon these variables with some noise. So again, I'm just going to represent as, see, this is the linear regression example for the representation where we have already train the model, and as per the given or train the model, we can assign the input attributes, and definitely we would be able to finding the validated value, and we can find out mm, statistical parameter which would be representing the precision level of the implemented model. So there are two different possibilities to represent the model. First model is required where we are just going to identify or form the model for the calibration, validation, and testing. And the second is it the model is already pre-trained, and definitely we have to use this particular model by the different number of inputs for finding the outputs, and these obtained outputs would be considered again for accuracy and precision point of view. So definitely this program is demonstrating the glucose dependencies of the different variables. So over here I have taken the pretend model where we have taken the inputs, where we have taken the inputs attribute. Definitely these are the attributes where we have selected the features. So generally the regression model is the regression model is not we can say finally it is linear or non-linear. It is depending upon the size of the data, it is depending upon the nature of the data, it is depending upon the different prediction level of the data. So definitely we are going towards the accuracy or precision. So it is required to justify the model which we are going to deploy, which is linear or non-linear. So if I'm just going to deliver the regression model, so the regression model contains the dependent variable and independent variable. So dependent variable definitely would be depending upon the independent variable, which are the explanatory variable, and explanatory variable would be always the input variables. So over here the age, BMI, blood pressure, and insulin, these all are the explanatory variables which are required to identify or justify the glucose values, or we can say the dependency of the glucose value. So right now it is being discussed over here. So in the first step we have called the libraries. In the second step we have discussed the data, we have represented the data. In the third step we have called the equations which is required to identify the glucose level. In the third level we have to go for the data framing. So whenever we are going to data frame into the df is equals to pd dot data frame, so we are going to frame the data into the form of the age, into the form of the BMI, into the form of the blood pressure and insulin, and definitely we can identify the values. So we have taken the input features. So four different input features have been taken. These are age, BMI, blood pressure, insulin, and glucose could be considered as the output. And we are going to deploy the linear regression model. So this linear regression model will be the model for the degree one. So we did not represent any kind of the derivative during this model. So we are going to represent a normal linear regression model for the for the prediction point of view and validation point of view. So for this prediction point of view, we have called the model, and we have called for the model is equals to linear regression, and this model dot fit x5, which represent the model is being trained, and the prediction would be completed by using the by prediction is equals to model dot predict, where we are using the x. This capital X is representing the capital is representing the four different features for the glucose represent dependency representation. So whenever we are going to couple all these four features as an input, we can predict the output value, which would be glucose dependencies. And definitely we are going to evaluate the model. So before evaluation of this model, we have to configure the data. After this configuration of the data, we have to train the model. After this training of the model, it is required to evaluate. For the evaluation, it is required to get the intercepts, because intercepts and the coefficients are forming the equations, which is the computing model for for data representations, for data predictions using the particular method of the regression. So for the particular method of the regression, we are going to find out the intercepts, we are going to find out the coefficients, and after find out these individuals and the role play parameters, the equations could be formed. And after the formation of the equations, we can identify the predicted model, sorry, predicted output values. And predicted output values could be differentiated with the reference values. On based on these particular differences, we can identify the correlation coefficients, we can identify the mean square error, and we can identify the root mean square error values on different statistical parameters, which would be responsible to represent the optimized model or not. So after the all kind of the optimizations, evaluations, and predictions, we have to represent the visualizations, and the visualization could be possible between the actual and predicted glucose values. So for prediction, we have to plot the values. We have to write down the different, and these are the very normal syntax and instructions are there for the visualizations of the data, where we can represent the actual value, which would be considered as a x-axis, and predicted value, which we consider bi-level axis. And after the plottings of the data on the x and y-axis, the scatter plot could be considered. The scatter plot could be built over there. And this is the complete code for the normal linear regression model for the glucose prediction, where we are using more than two inputs. And this particular program is for the utilization where we have the pre-trained model, where we have already the
Uh, Pratik, are you there? Pratik, are you there? Pratik? Pratik, you are not audible. Yes, participants, I am not sure whether Pratik is audible or not because I am not able to hear him. Yes, is he audible or it is for me only? Okay, okay. Thank you, Swin. Pratik, you are not audible. Not for me, but not for all. Yes, yes, yes. So that's what I conveyed him by phone. But he was in impression that he is audible. Okay, maybe he will join back in few minutes. But participant, sorry for inconvenience. I think the speaker has lost the internet connectivity, so he is joining from some other place. Okay, maybe he will be joining in 5 minutes. Sorry for inconvenience.
Sir, I hope I'm audible right now.
You are audible.
Not audible this time, sir?
Yes, yes, you are audible. Please go ahead.
Yeah,
Share
yeah,
your
I'm
screen.
going. Yes, sir. Okay. Sir, screen is visible, sir?
Yes, make it
Uh,
full screen.
sorry, sir. Sorry, sir. I'm sorry for interruptions. Definitely, it was internet disconnected. That's why, sir. So
No,
I
no,
was
no issue, no issue. Pratik, you can continue. You can have a 10, 15 means you can go up to 6:15. There is no
okay.
problem.
No
Okay, you
issue,
have
sir. I
20
don't
minutes more.
know. It was stopped where it means the slide number. It was 31, 32. I don't know from where it was the
So you
disconnected.
start from 32, 32.
So it was 32. Okay. So
Yes.
I was discussing about the predicted model representations. So after the predicted model representations, it is required to represent the intercepts and the coefficients. And after the getting the intercepts and coefficients, the model could be represented as a formed model, and this model is the trained model for the validation and testing point of view. So definitely after this after this trained model, getting this trained model, we would have the parameter representations uh, as a correlation coefficient, that is R score, R square score, mean square error, and other statistical parameter could be represented for the representation or analysis of the regression model. So for the visualization point of view, we can have the actual and predicted glucose value, which would be considered as a is which would be considered as a representing of a scatter plot. So definitely we are going to plot the values of the glucose, which could be confirmed from the four different input parameters and the reference values. So the x-axis could be represented by the reference glucose values, and y-axis could be represented by the predicted glucose values. And based upon the actual and predicted glucose values, we can plot the scatter diagram, and definitely this could be considered as the analysis of the data for the parametric realizations and the algorithm, precise algorithm formation over here. So for the example of this second multiple polynomial regression for the Python, so definitely, so I'm just going to segregate two different examples. The first example is going to represent for the pre-trained model, which would have the constraint to represent the data by the equations. The glucose is equals to 60 plus 0.5 multiplied by age and something else. And definitely this example is going to conferred by the second example. In the second example, we are calling two different rows for the inputs, as we have taken to independent variable as a input, and two different input variables will be represented for the confirmation or prediction of the third variable. So this polynomial regression, multiple polynomial regression, is a normal example for formation of the regression model, where we have taken x1 and x2 are arbitrary constant values based input parameters, and y is normal input values, which would be confirmed by the two input values. So these two input values are the channel values we can consider over here. So as a process, we have to frame the data. So data could be framed by the data which have been taken over here, and definitely the data could be framed, and it is being separated as the data is into the Excel format, where we have the different columns. Starting two columns would be the inputs, which would be considered as x1 and x2, and the third column would be considered as output, which is the y, which is represented by the y variable. And here we have to generate the polynomial features, where we have taken the degree of the data. So degree of the polynomial model represents the number of derivative terms we have used for the interaction point of view. So suppose if we are using the explanatory variable, which are x1 and x2, so for the interaction point of view, there would be possibilities for the degree 2. If we are going to form the regression model for the degree 2, so for the degree 2, it would be the equations like a x1 square plus b x2 square plus c x1 x2 and plus d. The d could be considered as a constant, where a b c, all these are the coefficients, and based upon these four values, the intersets will be considered. So x1 and x2 multiplication and their own derivatives represent the interaction of the models. And by using these interaction terms, because we have taken two inputs, so there will be number of interactions mod values would be 2 to the power 2, so it would be 4. So we have taken the number, the degrees, which is equals to 2, which is representing the derivative terms of the polynomial factor, which is equals to 2. So over here, this in this program, we have to form the equations, where the equations is not given as a pre-trained equation. So we have to create the equations based upon the input values. So first of all, we have to provide the fit of the linear regressions over here. So we have to provide the data to train the model. After this training of the model, by using the model dot fit, by using this fit instruction, the model is being trained, and we have the representation of the predicted output by the trained model by using the x poly, and we have to evaluate the r square and the RMSE value and then MAD value, uh, as a different statistical parameters, and we can identify the number of coefficients which are useful for from the equations. We can identify the intercepts which is required to model the regression equations, the computing model. So after this formation of this one, all these things, we can again use this particular equation for the validation and testing point of view, and we can analyze the different statistical parameters based upon the available number of inputs to confirm the model is feasible or not. Okay, so again, I am just going to represent the next example for the four input variables as a channel values, and if we are taking the number of derivative terms which are equal to 3, so polynomial degree 3 we have taken. So this time I'm just going to represent as a steps. So as a step, so we have to call all the important and required libraries. So the library, so this is actually the primary task, and this is the task which is required to recall the libraries for the data creation, data manipulations, data preparations, data processing, and finally the confirmation of the predicted model. Based upon the confirmation of the predicted model, we have to prepare the statistical parameters. So for all kind of these process, we have to call the libraries. So by the first step, we are importing the libraries. In the second step, we are generating data. Suppose if we are having the data, then we can call by using the directory path directly, which is easily stored, or which is easily available in the desktop computer where it is available. And the next, if the data is available online using the copy and paste to URL, you can directly call the data for the framing point of view. Okay, so here I'm just going to generate a data or load the data. So we have taken the number of samples which are 100. So four input channels data we have taken. So again, the number of input features which are 4, and the n is going to represent by number of samples we have taken. Okay, and definitely these number of samples and features are being considered for the informations of the linearly or non-linear relationships over here. So again, for the next step of the process, it is required to split the data into the train, validation, and testing purposes. So we have the proper standard ratio for the data training, data validation, and data testing. So 70% data of the overall data has been considered for the training purposes, and rest of the 30% data would be considered for the validation and testing purpose. So for the training purpose, we have taken the 70% data. So for the 70% data, we have taken the xtrain variable and xtemp variable uh, as a input feature, and we have taken the byte train and a byte temporary the variables. So we have to train the data, we have to test the data. For this training and testing point of view, we have to get the data into the different size. So we have to split into the size. So where we have taken the total test size which is equals to zero point 0.3, and where we have taken the random state. So random state is this arbitrary state. It is required to revoke. If we are writing any number of state, it is not a big issue, but we have to identify the test size. I said we have taken the test size, it is zero point 0.3, so we have taken the 0.3. We have taken the temporary or test size, that it is 0.5. So again, I'm just going to reshape the data. It is required to reshape the training data, the validation data, and testing data as a as a as a representation of the data, where it would be 700 out of 1,000. If you just look out over here, as number of samples are 1,000, where we have taken the 700 samples have been taken for the four input features as a training data, and rest of the 300 samples data would be considered for the testing and validation purposes. So we have already segregated by using the splitting of the data by using the split command. And in the second, in the next step, for the which is the fourth step, for the polynomial features transformations. For this polynomial feature transformations, we have taken the instruction which is poly equal to polynomial features, where we have taken the degree is equals to 3, and we are going to include the bias which is false. So if we are considered the bias is equals to false, it means we are going to prepare the intercepts. We are not taking intercepts which is already pre-trained or predefined from somewhere else. So if we are forming, or we are just confirming the bias as per the data availability and data representation, then we can use the false as a representation for the include underscore bias. But if suppose we have the intercepts already which is predefined, so we have to write it is true. So we are going to false, we are going to represent the the bias which is represented by a false, as we are going to intercept formation. Okay, so here again we have taken the new different variables, input variables for the validation point of view, for the testing, for the input variables for the testing point of view. So we have segregated all the validation and testing data for the representations, and it is required to identify the polytransform, because polytransform we have taken the trained model for the validation and testing purposes. Again, so again I'm just going to represent to train the linear model. So if it is going to train, because it was the multiple model, so over here we are going to train the linear model, we are going to train the model. For the training point of view, we have taken already x underscore train poly and y underscore train. So x underscore train poly, which is represented by the input features, and y underscore train is the predicted output, which is represented by the trained linear regression model. And again, this is the next step, which is evaluate on the validation set. So after the formation of the equations, we see where we have the number of inputs. Suppose in the same situation we have taken the four input vectors. So input vectors x1, small x1, small x2, small x3, and small x4, where all the input vectors have been considered and reconfigured to form the equations. And this equation is of the linear regression model. So the linear regression equations will be formed for the training and validation purposes. So for the validation purposes, we have to identify the formed equations, and this formed equation would be considered by the trained model. And after this training of the data, we have to provide the train input values and train output values as earliest. So definitely we will get the predicted values from the output. This predicted value of the outputs uh, 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 is required to analyze the differences between the original, or we can say the reference output values. So two different output values, it means reference output values and predicted output values are representing difference anyhow. By using these differences, we can confirm the correlation coefficient, we can confirm the root mean square, mean absolute difference, and mean absolute error. So by using this statistical parameter, we can confirm the model has been trained by particular this particular accuracy level. And evaluation could be possible by using the validation set of the data, by testing set of the data. So validation and testing performance could be done by using the predicted model, or we can say the trained model, and we can apply the different inputs sets for the prediction point of view, using the different input vectors. So we can evaluate that model, we can test the model for identifications, for optimizations point of view. So hope so that you uh, have some ideas regarding the equations and the instructions which are depending upon the different conditions. Actually, the preparation of the complete program, it is depending upon the availability of the equations, availability of the models, availability of the uh, uh, predefined functions. As we have the number of input variables, we have the output variable. So it is depending upon the availability of the equation. Suppose if the equation is required to form, then definitely we have to go for the training. After this training, the equation is formed, and validation testing could be performed after on the evaluated equations. So this is the first condition. And if already intercepts values have been provided to you, then definitely you have to use this reformed equations for the testing and validation point of view. So this is the a particular example of the glucose predictions by using these parameters that will be helpful for arrangements of the linear regression model. That it could be considered for the glucose prediction. Okay, and multiple polynomial regression model could be used for the prediction when we have more than uh, um, input variables. So if we have two different input variables, we had different degree level that we can use. So the conditions are the different. If we had a different degree models, we have the different more non-linear data, that definitely we have to use number of derivative terms. And that if you increase the number of derivative terms, the computation time will be increased, and definitely the cost will be increased for hardware perspective. So there are different aspects for using the different regression models. So similarly, we can use support vector regression also, we can use ridge regression, we can use logistic regression. The logistic regression will be used when we are going to find out the predicting model or forecasting model based upon the different classifications of the output responses depending upon the input arguments. So all these vectors can be used. So based upon the neural network, based upon the different trees model, we can predict the output based upon or accordingly independent variables. So these are the examples, and that is the flow in the Python. It is the advantage. It is one of the big advantage for use all these kind of equations, that where we are using the Python, we have almost same process and stage to form the program. It is very easy to learn the program, it is very easy to import the library, it is very easy to generate or load the data, where we can manipulate the data, we can slice the data, we can frame the data as per our requirement and availability of the data sets. And definitely the polynomial features transformation could be possible by using the different polynomial degree. We can change the polynomial degree, we can change the equations. And suppose by you somewhere else we have already identified the equations, and we have to form the framework which is based upon the different regression models, then we can directly use this Python framework for the training, validation, and testing purposes. So I hope these particular steps are helping to you for the forming of the program and by utilizing other regression models. So uh, I hope I'm just having some questions. Amit sir, is there any questions and query?
Yeah.
Then directly
Participants,
it
we are
is
open for the
being asked.
question if you have. Yes, we are open for the question. If somebody is interested to ask, please.
Because these regression models are very useful. Those are working on the healthcare, those are working for the smart grid, those are working for smart cities, smart villages, and those people are working on the recent trends and era. So regression models will be helpful for the forecasting models. So whenever we are going for the simpler form of the computing models, the regression model is very useful, as usually the complicated regression models takes a very less computation time, and the computation cost will be comparatively very low. So definitely the regression formulas by using the Python and other different frameworks and libraries will be helping to all of us. That is the point.
Okay. So it seems to be currently there is no question. Okay.
Sir, there,
So
sir, no issue. If somebody will be having the questions, so please share my email ID and mobile number. And somebody is having the issues and problems, then I would be helping to the participants and the scholars
sure,
also. No issues.
sure, Pratik, sure, Pratik. Thank you for spending time with us. Thank you, Pratik.
Thank you, sir. Thank you to provide the opportunity for such kind of the event, and definitely this is the platform where we can interact to all the scholars and the researchers. We can provide the information. We can share our experience also. So it is good for all of us. Thank you, sir. Thank you.
Okay, thank you. Okay. So participants, we will have a 5 minutes break. Okay. At 6:15 we will start because already next speaker is with us. Okay. but possibly we can have a 5-minute breaks. Okay. So
Okay.
we will meet at sharp 6:15 for the next session. Our speaker is already joined with us. Okay, Dr. Farooq sir. So uh, please be over here at 6:15.